Okay, I'm going to calculate the area under this curve using rectangle approximation. First, I'm going to connect all my rectangles on the left with 4 rectangles and calculate the area of those 4 rectangles. And then I'm going to connect them on the right, and then I'm going to take the average of my 2. So right now, if you look at the graph, I have 4 rectangles, and each one of those rectangles is connected on the right-hand side. So first thing we have to do is determine how wide each one of those rectangles are and how tall. Now, I'm going from 0 to 4, and each one of them is equal width, so each one of them has a width equals to 1. And if I want to calculate the area, I need to know the height. So this height comes from the function. Notice I have a graph y equals 1/4 x squared. I need to know what that output is, so I'll just use my calculator real quick. Now, I will go ahead and start by plugging it in just as I see it. 1 divided by 4 times x squared, window from 0 to 5, x scale of 1's fine, and y I'll go from -1 to 5. And I get the same picture in my graph as I have on paper, and I want to know the height of this rectangle, so I can use my calculator, and what we're looking at here is an x value at 3. The height is going to be the y value, which we get from the formula. So when I plug in 3 into my calculator, I get the y value, or you can plug it into the formula just as well. So again, I'm using either the calculator or the formula directly by hand to get that y value, which is 2.25. To get the area, I'm going to have to multiply the width times the height. So 1 times 2.25. This one rectangle has an area of 2.25. And I'm going to do that with each rectangle. So again, when x is 2, I can find the y value, and again the width is still 1. I just need to find the y value to multiply it by 1. So when x is 2, I've got a y value of 1. So my width is 1, my height is 1, my area is 1. I go to when x equals 1 to get the height here. And that should be 1/4 or 0.25. And then for the first rectangle, it's when x equals 0, and obviously the y value there is going to be 0, so my area is 0. So now the area of these 4 rectangles comes from adding these 4 numbers together. So my total area that I estimated for my left-hand sum. Why did I put right-hand sum over there? That's connected on the left-hand side. Sorry about that. So my area for my left-hand sum is going to equal 0 plus 0.25 plus 1 plus 2.25. And that's a total area of 3.5. Now, when you're looking at these rectangles, it should be obvious that these rectangles are underneath the curve, and the curve would have more area than these 4 rectangles would have. So that's what I'm going to handle next, is the right-hand sum. So let's take a look at what those rectangles would look like. And I'm going to make them in blue. So when I connect it on the right-hand side, my rectangles are larger. This depends on the curve. If the curve of this function was concave down, that would not be the case. Okay, so what's interesting about this new area, and let me just shade it in real quick. So my new rectangles are going to go all the way up to here. And I'm just doing a rough job shading them in so we can have a decent visual. I apologize, it's a little messy. And of course the rectangle goes all the way down. That's important. So my new rectangles don't stop on top of the old ones. They're from the top to the bottom. Full-size rectangle. So that's my new rectangles. Now what's interesting about these new rectangles I've made, take a look at this rectangle here. This rectangle here, this right-hand sum rectangle, is the exact same size of a rectangle. Is the exact same size as this left-hand sum one. They're the same rectangle. Sorry, pointing in the wrong direction. So these two rectangles are the same size, which means I know the area of this rectangle here is going to be 2.25. And if we move over, this rectangle and this rectangle are the same size, so they have the same area, 1. I could recalculate it if you prefer, but I'm not going to. This rectangle and this rectangle are the same size. Anything on the left and right hand side, you should always have a matching pair. This has an area of 0.25. I'm putting it. And that means there's only one rectangle I need to figure out its area, and that's this one rectangle. So if I've done a left-hand sum, then I've done everything I need to for a right-hand sum with one less. So let's look at the area of this rectangle. Its x value is 4 because I'm connecting over here on the right-hand side. There we go. Trace. Let's try 4. So my height is 4, my width is 1, my area is 4. So we've started off with a left-hand sum, and that's this area. Now I'm going to do a right-hand sum, and notice the first one is going to be 0.25. That's that. Next rectangle plus 1. Sorry. Plus 1. Next rectangle plus, not 0. 2.25. And now my last rectangle gives me an area of 4. So the total area is 7.5. But I know this area is clearly too big. So when I look at the average of the two, (3.5) plus 7.5 divided by 2 equals 5.5. I end up with an average. Average of the two areas, 5.5, and I guarantee you that is a very accurate estimate of the area under the curve.